Okay, here's your geometry notes for section 2.5. You should have already been handed out 2 cheat sheets that go along with this. We're going to reference the first one as we talk about reason using properties from algebra. We'll kind of work our way into geometry proofs starting with some algebra. And if you look at cheat sheet 1, some of the things that we're going to address, the segment addition postulate and the angle addition postulate, we already know those from chapter 1. But it's spelled out here and reminds us that if B is between A and C, there's our if and only if, which means it's true both ways, it's a biconditional, then you can add 2 little segments and make a big segment. Or you can add 2 little angles and make a big angle. What we're going to look at with the algebra is the addition, subtraction, multiplication, and division properties, which says anything can be added to both sides of an equation. As long as you add it to one side, you have to add it to the other, or subtract it, or multiply it, or divide it. The distributive property is the last one, where, as we know, you distribute by multiplying into the parentheses. So how are we going to use that here? For example, here's an algebra problem. And again, I know you can solve the algebra problem, but we're practicing proving a statement using a geometry, logical argument, and method. 2x plus 5 equals 20 minus 3x. Write a reason for each step. The equation is on the left. The reason is on the right. First thing, add 3x to both sides. And reminder, you might have to pause the video once in a while to keep up as I go through this, because some of mine's already done. Add 3x to both sides. Why would you do that? Because over here, it will get rid of the 3x. Over there, it will combine the x's. And the reason for that is the addition property. As you use cheat sheets, or there's going to be 7 of them by the time we're all the way done, you have to write exactly what it says in bold, italicized, and underlined. And all has to be in there. Addition property. Then you have, and basically here you just did the regular math. 5x plus 5 equals 20. How did we get that? We combined these like terms over here. 2x plus 3x is 5x. So we get to write for a reason. Just simplify. That's just mathematically simplifying what we did with the addition property. From there, now, we want to get, since we put x's on the left, we need to get numbers on the right. So you'll subtract 5 from both sides. Subtract it here to get rid of it. Whatever you do to one side, you have to do to the other side. Our reason is the subtraction property. And again, simplify. Finally, we need to get rid of the 5. That's multiplied by the x. So if you divide by 5 on both sides, the division property. And our final answer is x equals 3 because we simplified after we did the division property. Let's do another example. Go ahead and write this down. Solve. -4 times 11x plus 2 equals 80. And like we said here, you do have to write a reason for each step. Write the problem down, the original. That's given information. And the first thing you'll do here is -44x minus 8 equals 80. Get my 80 on there. Why did we do that? Distributive property. Next up, we're going to add 8 to both sides, and what I'm going to do this time, I showed you the full out every single step by step by step. This time, I'm going to just go with negative 44x equals 88. How did we get that? We added 8 here, added 8 here, didn't show the work and need the simplify step. We can just go with the addition property. If you would like to show every step and all of the work you did, step by step by step, that's where the addition property gets shown. I added 3x to both sides, and then you have to say simplify. If you're not showing the work and you know to add 8 to both sides, that's the addition property. And then it'll finish with x equals negative 2. How did you get that? From the division property. So as you can see, I took out a couple of steps if you take out the simplifying steps and just go with the distributive, addition, and division properties. All right, cheat sheet number 2. Take a look at that. This has some more interesting information. I know it's probably a little bit too small for you to read right there. There's a huge glare on the screen. But the substitution property of equality, it works with equals or congruence. You can look at it on your paper. If A equals B, then A can replace B anywhere in an equation or an expression. You can replace it. That's why it's called substitute. If I'm not here one day, they replace me with a substitute teacher. If you're in a game and you get hurt or you get tired or you get too many fouls on you, they will put in a substitute. Something is going to go in its place. But notice it does have to be equal. If it's not equal, it doesn't work. You have to have it determine that it's equal. If I leave, they don't put a veterinarian in my place. Or if you are the quarterback and you come out of the game, they don't put a lineman in for you. So segments, it can work with segments, it can work with numbers, it can also work with angles. As long as the two measures are equal, you can replace them. Or the two angles are congruent. It works with equals or congruent, equals or congruent. Numbers, segments, and angles can all use the substitution property. The reflexive property, this one's so easy that it's hard. People goof it up and don't get it right because it seems like it should be called the no kidding property, like oh really property. Numbers, A equals A. That is a true statement. Segments, segment AB equals segment AB, the measure of them. Or segment AB is congruent to segment AB. Same with angles. The measure of angle A equals the measure of angle A. Or you could say angle A is congruent to angle A. That will come in handy, and it will be very necessary at some point. We won't need it quite yet, other than you have to recognize that it's called the reflexive property. When would you ever want to use that? Just a quick, you don't have to write this down, but why would you ever use that property? Well, segment AB. And maybe you're trying to prove something about triangle ABC and triangle ABD. Well, AB, that segment belongs to that triangle, and it belongs to that triangle. So in order to use it twice, you would need it twice in your proof. That would just be one example of when would we use the reflexive property. Symmetric, I have a tendency to ignore or not use the symmetric property too much. It basically says you can reverse the order if A and B equals A. Just switch them around, use them in either order. So we'll focus more on the transitive property of equality. That again also works with numbers, segments, and angles. It says if A equals B and B equals C, then A has to equal C. You have to have three things related to each other. If you know A and B are the same, and you know B and C are the same, then it only makes sense that A is the same as C. If you are the same age as your friend, and your friend has another friend that's the same age, then you and your new friend must be the same age. Bob is the same age as Billy. Billy is the same age as Susie. Therefore, Bob and Susie are the same age. We know that because they're both the same age as Billy. It works with the measures of segments or congruence of segments. Notice if AB is equal to the measure of CD, CD and EF are the same. Therefore, measure of AB equals the measure of EF. Notice equals equals equals, equals equals equals, congruent congruent congruent, equals equals equals, congruent congruent congruent. You have to have three pairs. of statements for this to work. You have to have 3 pairs of statements for this to work. And every time they have a common segment or a common angle. If A is congruent to B and B is congruent to C, then A and C are congruent. That's our transitive property. What are we going to do with that? We're going to use cheat sheet 1 and cheat sheet 2. Remember, cheat sheet 1 had the segment and angle addition postulates on it. In the diagram, the measure of AB is equal to the measure of CD, and they have tick marks there to show you. We have to show that all of AC, if those 2 little segments are true, how can we show that all the way from A to C is the same size as all the way from B to D? And we can't just say, because it is, because you added a stick to it. So we're going to start out with the given information, AB equals CD. And we're going to have a reason over here, and the reason that we know that the measure of segment AB equals the measure of segment CD is because that was given to us. Next up, if I have the measure of segment AB, I know that I want AC for my final answer. How in the world am I going to get AC for my final answer? Well, it looks like I have to add this piece to it. I'm going to add BC. If I have AB, I'm going to add BC. But then we just talked about in our rules of algebra, and it works for segments and angles, you can't add something to this side of the equation and expect it to still be equal. You have to add it here. You're going to also add it over here. We're going to add BC both to this side and to that side. Why can we do that? That's the addition property. Well, then from there they tell us, okay, I know that AB plus BC equals AC. And I can look through all my cheat sheets and try to figure out why, but I could also look at the picture. If I take AB, which is right here, and I add BC to it, altogether I'm going to get AC. That's from chapter 1, but it's also on your first cheat sheet. We know that that's true because of the segment addition postulate. It even has the same letters for us. So we have to use over here the segment addition postulate. I just put POST, P-O-S-T. Well, then they're working with the other side of the segment, and they said that if I took CD, which is right here, and I added it to BC, altogether when I put them together, I'm going to get BD. Well, that again, 2 little sticks makes a big stick. Why is that true? The segment addition postulate. And finally, we can now say that AC equals BD, which is what we're looking for. And why does AC equal BD? We have to go all the way back through the entire proof, through the entire reasoning, and say, what do I know about AC? I know that AC, that's the only place else I see it. It's the same as AB and BC. Well, in cheat sheet 2, it says if you have 2 things that are the same, you can substitute them. You can take AB plus BC out of any other equation that you have, AB plus BC. I'm going to take that out. I'm going to put AC in its place. So now my new statement is AC. I can also do that to BD. Where's BD? It's right here. BD is the same as CD plus BC. Those are equal. They're both quarterbacks. They're both point guards. They're both pitchers. So we take CD plus BC out up here in our equation, and now we replace it with BD. So we just turned this equation into this equation by adding a couple steps in between of how are they related to each other. We need a connection. How do those two little segments equal the big segment? What lets us take this out and put something in its place? Take this out and put something in its place? The substitution property. Substitution property lets you remove anything that's equal and put something else in its place. So there's our reason for our final answer. We did the segment addition postulate twice because we were talking about two different segments. And that gets a little bit complicated, but the more of these we do, the better you'll get with them. Let's try it. It's the same idea here, but we're going to use angles just to get used to looking at them with angles. Take the time, pause your video, and write all this down. Draw the picture, write the information, use the information given to determine whether angle CBD is congruent to angle EBA. And notice there are two congruent marks there, and the angles are measured 1, 2, and 3. Okay, pause it, and when you come back, we'll talk about angle 1 being congruent to angle 3. Why is angle 1 congruent to angle 3? Because they told us it was. That is given information. Why is angle CBD congruent to angle 1 plus angle 2? Trace it if you need to. See if it helps you. Angle CBD. Why is that congruent to angle 1 plus angle 2? Oh, because it's two little angles, and those two little angles make a big angle. What says two little angles make a big angle? The angle addition postulate does. Go ahead and write the next step down. Angle EBA is congruent to angle 3 plus angle 2. Same thing, just different part of the diagram. EBA, they said that you can take angle 1, angle 3 and angle 2 and put those together. And we can by the angle addition postulate. We need a reason for everything. Everything needs a reason. Take a look at the top. We're trying to prove that angle 1 is congruent to angle 3. We're getting there. We're not there yet. But we at least have angle 1 and angle 3 in our equation somewhere. So what do they do from there? They tell us that angle EBA is congruent to angle 1 plus angle 2. Well, that's weird, because if you look at the diagram, angle 1 plus angle 2 has nothing to do with EBA. It's 2 and 3. But according to our cheat sheet number 2, look at these two statements. Angle EBA is congruent to angle 3 or 1 plus angle 2. The only thing that's different is this angle 1 was replaced this angle 3. That's because up here it said it could. If they're the same, this guy comes out of the game, this guy goes in. What lets us do that? The substitution property. Anytime you have two things that are congruent or equal, you can replace them. And that helps us because we already have angle 1 plus angle 2 up here in our statements. Angle 1 plus angle 2 is right here. What do we know that that's the same as? We know it's the same as angle CBD. Go back and look at cheat sheet number 2. Check out the transitive property. Where's my cheat sheet number 2? The transitive property. If you have three things that are congruent, with a shared middle, a shared in between, take a look at what we have. Angle CBD, here's the first thing, is congruent to 1 plus 2. But 1 plus 2 is congruent to EBA. Oops. So we can go from CBD to 1 plus 2, 1 plus 2 to EBA. We replaced it. If we know these are related to them, they must be related to each other. Transitive property. Now, at this point, you shouldn't just move on and try to write the next stuff down. You have to go back and think your way through this. Would you be able to come up with this on your own? Someday, in the near future, you will be able to. Right now, they're going to give you the statements. You have to come up with the reasons. But eventually, you're going to be given statement number 1 and statement number 5, and you have to come up with everything in between. Go back, rewind, look at it again, see if you understand it. What questions do you have? All right, from here, we're just going to come up with the reason. Use your cheat sheets, look them over carefully, get to know them really well. Name the property of equality that the statement illustrates. If it says the measure of angle 6 equals the measure of angle 7, then the measure of 7 equals the measure of angle 6. Pause it, write this down, take time to look it up, see if you can find it. And I think that you might find it on cheat sheet number 2. That says the symmetric property. You can rearrange any two things as long as they're equal. 6 equals 7, 7 equals 6. Symmetric property. Write this one down. If the measure of segment JK equals the measure of segment KL, and the measure of segment KL equals 12, then the measure of segment JK must equal 12. If U equal U, and U equal U, and we have a shared opponent that knows that is related to that, then we can conclude that those two are related to each other by the transitive property. Now hold on and think about this for 1 second. It can get confusing sometimes because we've already talked about that if two things are equal, you can take one thing out and put something else in its place. You could just take this KL out of here, put JK in its place because they're equal. Then it's the substitution property. There's a very thin line and a very, very small difference sometimes between the substitution property and the transitive property. On this one, I probably would allow substitution. Because you're comparing segments and numbers. It's not just segment, 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 number, 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 number. It's a mixture of segments and numbers. So I would be okay with substitution property. And no, you can't abbreviate these. If you call it the sub-property, we don't know if you mean substitution or subtraction. Here's the easy one. So easy it's hard. If the measure of angle W, why does it equal the measure of angle W? Go find it on cheat sheet 2. Anything is equal to itself is right there, the reflexive property. All right, keep your cheat sheets handy. Don't put them away as you work on your assignment. Your assignment is page 100. You have to do all of those. And, of course, you may need to still finish up your assignment from 2.2 with all the writing that you had. All right, good luck. We'll talk this over tomorrow.